No, yeah, correct.
Start seeing it now.
Okay, so we are talking about slack catcher. Let us go in this node number 2. We'll go in node number 2. And this PSH, what is tag number?
PSDH.
05.
5, 6, 7. I think.
This, I
No,
think
this
this we have
No,
taken, right?
this is alarm, not this one. Should be 0, 5, 6, and 7. You can search gigs, I think.
Why are you looking to trip function? I'm not understand.
So
Why we
can
look
you,
here trip
Yeah,
function?
correct.
I'm not understand what is the
what is the
strategy.
tag number?
Excuse me, Chairman. Why are we looking for the trip function?
No, actually, I mean, there is a definition. Was it considered a job? So I want to put here yes, no. I want to put yes, no here.
Yes.
Yes, okay. So answer is yes. And in seal, we have considered this in layer of protection.
Yeah.
So no problem.
Yes.
I mean, yes, okay. So guys, this is valid alarm as per this definition. This is valid alarm. What is the likely cause of alarm? What is the likely cause? Why there is a high pressure in this this one? Some valve closure and process subject, right?
Depends on the root causes. It depends on the root causes.
Yeah. So there are many causes in the hedgehog.
Yes.
We don't need to put all the causes here. We need to see the high pressure in the slack catcher because of closure of some downstream valve and process substrate.
Yes.
Yes.
First one, I think.
Closure of
Operator.
any down.
Not any slack catcher. It is we have only one slack catcher.
Oh, yeah, you're right. Closure of closure of
Manual valve or control valve, I think.
No, downstream we have SDV. Locked
just a minute.
outlet. Yes.
Just inlet also.
Potential closure of any downstream valve.
Okay, POTE potential